Hi guys, so today we'll be solving this problem called validate binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and the right subtree must also be binary search tree. So they have given an example of a tree, and here the left subtree has nodes which is less than the nodes key, and the right subtree has nodes which are greater than the nodes key. So therefore we return true. Similarly here, the left subtree has nodes less than the nodes key, but in the right subtree you can see that uh, there are nodes which are less than the nodes key, which is 4 is less than 5, but we need all the nodes key which are greater than the nodes key on the right subtree, and which are less than the nodes key should be on the left subtree. So that is the basic property of binary search tree. So in any binary search tree we'll have values which are less than the nodes value on the left side, and the values which are greater than the nodes value on the right side. So the naive approach, what we can do to solve this problem is to traverse the whole uh, tree and to check if every element has left and right subtree following the property of binary search tree. But the time complexity would be very bad in that because we have to traverse the whole uh, tree. And also there would be some corner cases which you would not be able to check just by just by checking if the left subtree has smaller than nodes key and right subtree has greater values than the nodes key. So what we'll do is that uh, we can traverse the whole tree and in order fashion. And you must remember that every time you traverse a tree in order fashion, their uh, values which are stored are always sorted in binary search tree. So you check if the values that you store, so basically you traverse through the tree and you store the value in some vector, array, whatever you call it, and you store the in order traversal of the tree, and you check if that in order traversal is in the sorted order. If it is not, then then the tree does not satisfy the property of binary search tree. If it is, then it satisfies the binary search tree, and therefore it is binary search tree, and you can return true. This is one approach that you can do. The other approach that you can follow is that you check if uh, the left subtree has uh, has basically, in this second approach, you don't store it somewhere. You don't store the in order traversal, but what you do is you maintain a previous pointer. You maintain a previous pointer to check if every node value is smaller than the previous node that you visited. By doing this, you will always uh, be satisfying the condition of that in order traversal contains always a sorted order of binary search tree. So you have previous pointer which stores the previous value in the in order traversal, and you check to the current value. If the previous value is greater than the current value, then you return false. Otherwise, you return true. So let's implement this approach. It's a very easy approach which reduces the time complexity of and space complexity of storing the in order fashion somewhere, in order traversal somewhere, and you don't need to store it anywhere and uh, increase the space complexity. You can just do it by maintaining a pointer which is previous, and you just check if this value is greater than equal to the current value. So base condition would be written as if root is equal to null pointer, then we return false. Otherwise, we check if is we run a recursion for the left subtree first. And if it is not valid, the left subtree is not valid, then we return false. And then we check if previous value previous is not equal to null pointer and previous value is greater than equal to uh, previous is equal to null pointer and previous value is greater than equal to root's value. All right, so this is the condition that we check. And so if it is, then it doesn't satisfy the in order, the sorted fashion which we said earlier, that the in order traversal should be in sorted fashion, but the previous value is greater than the current value, so that means it is not in a sorted order. Therefore, we return false, and we check if is valid BST root right, return false. If the right subtree is not valid, then we return false. Otherwise, we return true. All right, let's run the code to check if um okay. Hi guys. So mistake was that we were trying to return true here, and we were trying to return false. Whereas if it is a null pointer, we return true, because a null tree is a BST. So we have to return that as a true value. So that was the mistake. So um, I hope you guys understood the problem. It uh, is a easy problem which you can do by naive approach, or you can try this approach, which is a better version of it, and the time complexity becomes just of uh, h, which is the height of the tree. So I hope you guys understood the problem. Thank you.